Hi guys, welcome back to my YouTube channel. So in this video, we're going to discuss about a topic in thermodynamics. So this is all about pressure. You can also include this topic guys in our fluid mechanics subject. Okay, so pressure and stress are somehow similar because they are both force per unit of area. But pressure guys is the force exerted, the normal force exerted by a fluid per unit of area. So basically, the difference between pressure and stress is that we use the term pressure in thermodynamics or fluid mechanics when we are dealing with fluids, and we use stress when we are dealing with solids. So yung stress ginagamit natin yan guys sa strength of materials. But here, we are dealing with fluids like air, water, anything that flows. It's a fluid. We use the term pressure for the normal force exerted by that fluid per unit of area. Okay, so pressure will always be the force exerted by that fluid per unit of area. So we use the letter P or the variable P when denoting pressure. Okay, so here, say we have this container, and inside the container we have a fluid. Let's say this is water. Then we are required to find the pressure at the bottom of this container. Okay, so basically guys, dalawa yung pressure na nag-exert sa bottom. Let's say, what is the pressure here? Let's say pressure P at this point, at the bottom of the container. So yung pressure na nag-act doon sa bottom ng container is actually the sum of the atmospheric pressure, kasi this is exposed sa atmosphere. Merong pressure na in-exert yung atmosphere. That's what you call the atmospheric pressure or barometric pressure. Then, we also have the pressure exerted by this fluid. Let's say, itong fluid natin guys, meron siyang certain height. Let's say H. So, the pressure P at the bottom is just equal to the pressure exerted by the atmosphere plus the pressure due to the height of the fluid. Now, what is the pressure due to the height of the fluid? So, itong fluid natin guys, inside the container, meron siyang weight na ine-exert dito. So, meron siyang bigat na ine-exert dito sa bottom ng container. So, what is the pressure exerted by that weight? So, what is the weight? What is the weight of this fluid? Pressure due to height just equal to the force of the fluid, force exerted by the fluid per unit of area. So, the force exerted by the fluid is just the weight of the fluid. So, yung area here can be expressed in terms of the volume of this fluid. So, itong area is just the area wherein yung weight ng fluid is under contact. So, ito yung area niya. Okay, so yung circle na yan. So, this is the area. Pwede nating mahanap yung area in terms of volume. So, yung volume natin, recalling geometry, is just the area of the base, area ng base, area nitong base, times the height. Okay, yung height ng ating object. Okay, so yung area can be expressed as volume divided by height. Okay? So, yung volume ng fluid natin can be expressed guys in terms of density. Okay? So, kung maalala nyo guys, density is equal to mass per unit of volume. Okay? So, therefore, we can say that volume is just equal to mass divided by density. Then, ito guys, is-substitute natin dito sa area. So, area is, okay, we have here mass divided by density times H. So, pinalitan lang natin yung volume in terms of mass and density. So, therefore, area can be substituted here sa ating formula. Okay, substitute natin siya dito. So, the pressure due to the height, so yung weight ng fluid natin is just equal to the mass of the fluid times the acceleration due to gravity. Then, divide natin sa area, which is mass divided by, we have here density, H. So, we can simplify this as, simplify lang natin guys, itong mass dito mag-cancel na siya. So, this becomes, so pressure due to height is just equal to density GH. Okay, so itong density G is just your specific weight. So, specific weight times H. Okay, so this is the formula for finding the pressure at a given height. So, ito yung formulang ginagamit natin in thermodynamics or in fluid mechanics. Okay, so therefore, ang pressure here at the bottom, yung pressure at the bottom is just equal to atmospheric pressure plus pressure due to height, which is density of the fluid here, yung fluid na ginamit, times the acceleration due to gravity, then yung ating height. So this pressure at the bottom of the tank, yan yung true pressure niya doon. This pressure is what you called the absolute. Ito yung tinatawag natin guys na absolute pressure. Siya yung true pressure at a given point. So the true pressure at the given point, hindi lang yon yung pressure due to height, because meron pang ina-exert na pressure yung atmosphere. So yung true pressure at the bottom is actually equal atmospheric pressure plus that pressure due to the height or elevation of the fluid. So this atmospheric pressure guys at sea level is a constant. So later on i-discuss ko yung mga values niya. So this expression here, which is the difference between, so kung ito-transpose natin magiging, so let's say transpose natin magiging absolute pressure, since this is absolute, minus atmospheric, then this expression here is what you call the gauge pressure. So yan yung tinatawag natin guys na gauge pressure. Okay, another explanation of those three pressures. Okay, so ito tinatawag natin guys na absolute vacuum pag zero yung absolute pressure. Okay, so ito yung reference point natin. So focus lang muna tayo dito guys sa figure on the right side. So absolute pressure, the true pressure at a certain location, at a certain point, a certain height is just equal to gauge pressure. As you can see here in the figure, so inad lang itong gauge plus atmospheric. So plus atmospheric pressure. So there's what you call guys a vacuum pressure. So focus tayo dito guys sa left side figure naman. So vacuum pressure is just a negative gauge pressure. So vacuum pressure is just a negative gauge pressure. So pag nag-negative guys yung gauge pressure natin, ibig sabihin vacuum pressure siya. So nangyayari yun guys if the atmospheric pressure is greater than the absolute pressure. So we all know that gauge pressure is just equal to absolute pressure minus atmospheric pressures. So syempre if atmospheric is greater than absolute, so magne-negative siya. Instead we are going to call it a vacuum pressure. So that's how it works in terms of the definition of pressure. So vacuum pressure is just a negative gauge pressure. Then we go here guys, punta tayo dito sa concept of pressure on varying heights. So pressure increase linearly. Okay, so pressure increase linearly. Ibig sabihin the deeper you go from the surface of the fluid, as you go deeper, mas lumalaki guys yung pressure natin. So height dependent ang pressure. So at this same level, pressure sa A, pressure sa B, pressure sa C, D, E, F, and G are equal. Considering na same height and same fluid yung nag-i-interact dito sa surface, which is water. Okay, now dito guys, although same height yung H and I, dito sa I, water, but dito sa H is mercury. So pH and PI are not equal. So we have this device, this is what you call the barometer. So barometer is a device used to measure atmospheric pressure. Okay, so mini-measure niya is the atmospheric pressure. That's why ginagamit rin natin yung word na barometric pressure as an equivalent term sa atmospheric pressure. So barometric pressure and atmospheric pressure are the same terms. Meron tayo ditong parang tube, inverted tube, wherein if the atmosphere, so yung pressure ng atmosphere, meron siyang force of course, ipupush niya itong fluid, then the tendency of course, fluid will rise up here on the tube. So tataas yung fluid sa tube because nag-push tayo ng atmospheric pressure here. Okay, it will rise at a certain height H. So yung pressure dito sa B is equal sa atmospheric pressure kasi same level lang sila. Then yung pressure dito sa B is just equal to the pressure here on this empty space. So dinidisregard natin yung pressure of the air inside that gap, inside the tube. So yung pressure there is approximately equal to 0. So ang natitirang pressure na lang is the pressure due to this height, which is, so yung pressure ng atmosphere is equal to density G H. So yung atmospheric pressure natin guys at sea level, so that is measured in atmosphere. So 1 atmosphere, 1 atm. Okay, so 1 atm, standard atmosphere natin, 101.325 kilopascals. Since pressure is force per unit of area, this is measured in terms of Newton per square meter or Pascal, or kilopascal, that is kilonewton per square meter. Or this is equivalent to 14.7, that is PSI, or pound force per square inch, or this can be equal to 760 millimeters of mercury. So if the atmospheric pressure, guys, is 101.325 kPa, the height of this fluid, which is mercury, inside this barometer will rise at a height of 760 millimeters. So yan yung concept natin. So how did you get the 760? Okay, using this atmospheric pressure is equal to density gh. So if the pressure is equal to density gh, then if P is equal to, the pressure is equal to 101.325 say kilopascals, that is normal atmospheric pressure. So gamitin natin itong concept. So 101.325 kilopascals equals density of mercury. What is the density of mercury? So density of Hg, given, that is given as 13,600 kilograms per cubic meter. So that is standard ginagamit natin. So times G, which is standard tayo, 9.81 meters per second squared. Compute natin yung H. Dapat 760 yung makuha natin to prove this conversion. Okay, so this becomes H equals, so 101.325. This is kPa, guys. Convert natin siya, guys, to Pascal muna para maging newtons. Okay, so kilopascal. So this is 1,000 pascals per, we have here 1 kilopascal. Then yung Pascal, i-convert natin to Newton per square meter. So we have here Newton, 1 Newton per square meter. So that is 1 Pascal. Okay, so divided by 13,600 times 9.81. So 13,600 kilograms per cubic meter times 9.81 meters per second squared. Okay, so this will cancel out. Cancel na yung kilopascal here. Pascal will cancel out here. Then itong kilogram meter per second squared is a newton. Okay, pwede natin siyang i-convert to newton. So 1 newton, that is 1 kilogram meter per second squared. Okay, so cancel na yung equivalent unit ng newton. So kilogram here will cancel out, meter per second squared will cancel out, and newton here will cancel out. Okay, it leaves us cubic meter divided by square meter. So that is in terms of meter. Okay, so ang unit nito, guys, is in terms of meter. So i-convert pa natin itong equivalent niya into millimeter para ma-prove natin yung 760. So conversion natin is 1,000 mm per 1 meter. So compute natin yung 101.325 times 1,000. Okay, so 101.325 times 1,000 divided by 13,600 times 9.81. Okay, so 0.7595. That is meters. Convert natin to millimeter. Multiply by 1,000. So we have here 759.5. Okay, so H is 759.5. We have here millimeters of mercury. Ibig sabihin, guys, na-prove natin na 760 ginagamit sa thermodynamics, approximately 760 millimeters. Okay, so round off natin yan. So therefore, at normal atmosphere at 101.325 kPa, that is 1 atm, yung rise of mercury inside the barometer is 760 millimeters. So that's how you convert those pressures. Okay, so let's solve, guys. Solve tayo ng sample problem to further understand this concept. In this first problem, guys, we have expressed a pressure of 155 kilopascal gauge as an absolute pressure if the local atmospheric pressure is 98 kilopascals. So basically, guys, this 155 kPa kilopascal gauge should be converted into absolute pressure. So absolute pressure is equal to atmospheric pressure plus gauge pressure. Okay, so we have absolute pressure, that is atmospheric pressure. So the given atmospheric pressure is 98 kPa, so 98 kilopascals. Then the gauge pressure is 155 kilopascals. So absolute pressure is equal to, that is 253 kilopascals. So absolute pressure, lagyan natin ng A sa katabi ng kilopascal to denote that this is absolute pressure. For the second problem, we have expressed a pressure of 225 kPa absolute as a gauge pressure. The local atmospheric pressure is 101 kPa. Okay, so atmospheric pressure is given by, so we have here 101 kilopascals. Then we have the absolute pressure as 225 kilopascal. So what is the gauge pressure? So absolute pressure is equal to atmospheric pressure plus gauge pressure. So gauge pressure is equal to absolute pressure minus atmospheric pressure. So gauge pressure is equal to, ang absolute pressure natin is given as 225 kilopascals, then atmospheric natin is 101 kPa. So the gauge pressure is equal to 225 minus 101 kilopascals. So that is 124 kilopascal gauge. So 124 kilopascal gauge. So this is the answer for the second problem. For the third problem, guys, we have expressed a pressure of 10.9 psi. This is absolute as a gauge pressure. Okay, so we have the local atmospheric pressure as 15 psi. So we have here absolute pressure is equal to atmospheric pressure plus gauge pressure. So gauge pressure is equal to, we have here absolute pressure minus atmospheric pressure. So yung absolute pressure natin, that is 10.9 psi. Then we have the local atmospheric pressure as 15 psi. So that is equal to negative 4.1 psi. Okay guys, so this is a gauge pressure na negative. So we can also say that this is vacuum pressure. Okay, so we can say that this is 4.1 psi vacuum pressure. So pag tinanggal natin guys yung negative sign, ibig sabihin dapat i-transfer din natin yung term niya as vacuum pressure. But pag in-insert natin yung vacuum pressure sa ating problem, let's say, so absolute pressure is just equal to atmospheric, okay, that is minus vacuum pressure. Ang ating atmospheric pressure, that is 15 psi, then minus 4.1 psi. It will go back sa absolute pressure natin, which is 10.9 psi. So you have this fourth problem guys, express a pressure of negative 6.2 psi gauge as an absolute pressure. Okay, so mapapansin nyo guys dito sa problem natin, negative yung sign niya kasi ang ginamit niyang term is gauge. Okay, so pag ang ginamit nating term guys is vacuum pressure, positive yung makikita natin sa problem. Okay, so it can also be expressed like this. Express a vacuum pressure of 6.2, we have here psi as an absolute pressure. Okay, so these two problems are the same. Okay, so dito mapansin natin, gauge yung ginamit niya, naglagay siya ng negative, but dito, vacuum pressure yung ginamit niyang term, tinanggal niya yung negative sign. But this problem are the same. Okay, solve natin itong problem na to. Okay, so that is absolute pressure is equal to, we have here atmospheric pressure plus gauge pressure. So dito guys, walang given na value ng atmospheric pressure. So pag ganitong problem, walang given na value of the atmospheric pressure, we will assume a standard atmospheric pressure. So ito guys, naka PSI. So gamitin natin atmospheric pressure, standard atmosphere, that is 14.7 PSI. Then yung gauge pressure natin is negative, so negative 6.2. Okay, negative 6.2 PSI. Okay, so absolute pressure natin, that is just equal to 14.7 minus 6.2. Okay, so this is 8.5 psi absolute. So let's proceed to this fifth problem. So determine the pressure exerted on the surface of a submarine cruising 175 feet below the free surface of the sea. Assume that the barometric pressure is 14.7 psi and a specific gravity of seawater that is 1.03. Okay, so we have here submarine. Hinahanap natin yung pressure exerted on the surface of a submarine. So let's say ito yung surface ng dagat, that is seawater. Then we have the submarine here at a height of 175 feet. Okay, so we have, say this is the submarine here. Then yung height natin, the height of this submarine here is 175 feet. So assume a barometric pressure of 14.7 psi. So yung barometric pressure natin, so the atmospheric pressure is 14.7 psi. Yung specific gravity ng seawater is 1.03. Okay, so yung ating pressure, so the pressure exerted on the submarine, okay, let's say the absolute pressure, that's just equal to the atmospheric pressure plus the gauge pressure. So yung gauge pressure natin is the pressure due to height, that is pressure gauge equals density, okay, density ng seawater times the gravitational acceleration, then yung ating height which is 175 feet. Okay, so yung ating density ng seawater is not given, pero binigyan tayo dito guys ng specific gravity. So we can compute for the density of seawater. So the pressure at the bottom, that is absolute pressure. So absolute pressure is equal to atmospheric pressure. So that is given as 14.7 psi. Then yung gauge pressure natin is density gh. Okay, so yung density ng seawater, so that is the density of seawater times g times the height. So yung height natin, that is 175 feet. Hanapin natin guys muna yung density of seawater. So itong density g, this density g, okay, itong density g na expression can be also expressed in terms of specific weight. So we have discussed this on my previous video. So this density g expression is the specific weight. So this is just equal to 14.7 psi plus the specific weight of seawater times height. So yung SG natin, specific gravity of seawater, is just equal to the specific weight of seawater, specific weight of ating standard na fluid for specific gravity, that is water, H2O. Okay, so therefore, yung specific weight of seawater is just equal to the specific gravity of seawater times the specific weight of water. So at standard condition, that is 62.4 pound force per cubic feet. So in SI, yung specific weight ng water in SI, that is 9.81, that is 9.81 kilonewtons per cubic meter. In English unit, 62.4, okay, 62.4 pound force per cubic feet. Okay, so dito guys, English tayo, we will use 62.4 pound force per cubic feet. Specific weight of seawater, that is, so SG of seawater, 1.03 times specific weight of water, so that is 62.4 pound force per cubic feet. So that is 64.272. This is pound force per cubic feet. Okay, so eto guys, ang i-insert nating specific weight of seawater here. Okay, so H is given, we can compute for the absolute pressure at that height, pressure na nag-exert sa submarine. Okay, so we have here absolute pressure is atmospheric 14.7 psi plus specific weight of seawater, that is 64.272, that is pound force per cubic feet. Okay, so ito guys, this is pound force per square inch. Okay, so hindi natin siya pwedeng i-combine agad. Okay, so i-convert muna natin itong pound force per cubic feet. So we have here 1 foot per 12 inches. So this is naka-cube siya. So i-cube din natin yung conversion. So yung 12 is naka-cube siya. Specific weight times the height. So the height below the free surface, that is 175 feet. Okay, so this is 175 feet. So ito na-convert natin to inch. Okay, so ito dapat i-convert din natin to inches. So this conversion here, so we have 12 inch per 1 foot. Absolute pressure in PSI. So PSI na siya. So that is 14.7 plus we have this 64.272 divided by etong 12 cube. Naka-cube yon. Then naka-multiply ang we have here 175 times 12. Okay, so that is in PSI. Okay, so the pressure at that height, at that depth is 92.8. Okay, 92.8 PSI. So this is the final answer for this problem. So that's how you solve, guys. Ganun ang pag-solve natin ng mga pressure. Okay, so pressure exerted on the surface of the submarine is just the sum of the atmospheric kasi nag-push siya on the sea, and then yung pressure due to the height of the sea water, which is density gH. A gas is contained in a vertical frictionless piston cylinder device. The piston has a mass of 3.2 kilograms and a cross-sectional area of 35 square centimeters. A compressed spring above the piston exerts a force of 150 newtons on the piston. So if the atmospheric pressure is 95 kilopascals, determine the pressure inside the cylinder. Okay, sa analysis natin, guys, so the pressure experienced inside this cylinder is actually the sum of the pressures exerted by the spring. Itong 150 newton, meron siyang pressure na na-exert dito. Then the atmospheric pressure, then we have here the pressure exerted by the mass of the piston. So meron tayong tatlong pressure that is exerted inside the cylinder. So let's say the pressure inside the cylinder, let's say P sub I is the pressure inside the cylinder. Okay, so pressure inside the cylinder is the sum of the pressure exerted by the 150 newtons. Okay, yung 150 newtons spring, meron siyang force. Ito yung area niya, area under contact. So we can find the pressure. Okay, the pressure exerted by the spring plus the pressure of the atmosphere. Yun yung mga nagpo-push down doon sa ating piston, plus the pressure due to the weight. Okay, due to the weight of the piston. So let's find the individual term. Okay, so PS muna tayo. So P sub S, pressure exerted by the spring. Ito, 150 newtons yung force niya. So force over area. So 150 newtons divided by area. Area under contact is 35 square cm. Okay, so we have here 35 square cm. So this is square centimeter. I-convert natin siya, guys, to square meter para maging Pascal. Okay, yung Newton per square meter. You have here 1 meter per 100 cm. Then i-square natin because that's naka-square yung conversion natin. So this is just equal to 42,857 that is 0.14. Okay, Newton per square meter na siya, guys. Newton per square meter or Pascal. So 42,857.14 pascals. Then we convert this, guys, to kilopascal. So pressure ng spring is 42,857.14, that is pascals. We have here 1 kPa per 1,000 pascals. So that's just equal to 42.857 kilopascals. So atmospheric pressure is given by 95 kilopascal. So atmospheric pressure is 95 kPa. Then the pressure exerted by the mass of the piston. Yung pressure due to the weight, okay, weight of the piston is just equal to force over area. So yung force natin is the weight of this piston, which has a mass of 3.2 kilograms. Okay, so we have here weight all over area. So weight is just equal to mg, mass times acceleration due to gravity, divided by area. So the area under contact is still 35 square centimeters. So the pressure due to the weight of the piston is equal to mg over a. So that is weight over area or force over area. So mass ng piston, that is 3.2 kilograms. And we have the acceleration due to gravity, 9.81 meters per second squared. Then yung area ng piston natin, that is 35 square centimeter. Then convert natin to guys to square meter to convert this to Pascal. Okay, so we have here 1 meter per 100 cm. So this is squared. Then we have here 1 newton per 1 kilogram mass meter per second squared. Okay, so this will cancel out here. Kilograms meter per second squared will cancel. Cm squared will cancel. Remaining unit natin is newton per square meter. So that is Pascal. So the pressure due to the weight of the piston is equal to, we have here 3.2 times 9.81 divided by 35. Yung 35 na divide pa sa 100 squared. Okay, so we have here 8969. So this is 8969.14. Okay, so that is newtons per square meter, or that is Pascal. Convert natin siya guys to kilopascal. Divide lang natin by 1000. Now we can find the pressure inside the cylinder. So yung pressure inside the cylinder is just the sum of the pressure exerted by the spring. Yung force ng spring is 150. We can find the pressure, force over area. Then yung atmospheric pressure given. Then yung pressure exerted by the mass of the piston, which is 3.2 kilograms. Nahanap pa rin natin yan guys using the concept that pressure is force over area. So the pressure inside the cylinder is the sum of the pressures, pressure exerted by the spring and the atmospheric pressure. And you have here the pressure exerted by the weight of the piston. Okay, yung PS natin given as pressure due to the force ng spring, 42.857 kPa. We have here 42.857 kilopascals plus atmospheric pressure natin 95 kilopascal. Then yung ating pressure due to the weight of the piston, that is 8.96914 kPa. So we have here the pressure inside the cylinder as 146, okay, 0.8 kilopascal. I-round up natin to the nearest whole number. Okay guys, so this is approximately equal to 147 kilopascal. So this is the pressure inside the cylinder. So that's it guys. That's how you solve problems involving pressure in thermodynamics or fluid mechanics. In my next video guys, I will teach you on how to solve problems in manometers. So differential manometers, I will teach you on how to analyze those types of problem. Thank you for watching this video guys. I hope that you have learned from this video. So if you're new to this channel guys, just click the subscribe button and the notification bell so that you'll get notified on our future videos just like this one. Thank you guys. See you on my next video.